Hi, my name's Eli Holmes. I'm the lead of the NOAA Fisheries Open Science Initiative. Today, I'm going to give you a brief introduction to JupyterHubs and containerization and talk about how they help streamline and accelerate scientific innovation. So, what's containerization? Let's think about if I were to set up my laptop. Say I got a new laptop. I would install an operating system. Then I use R. I would install R Studio. I use Python too. I'd install that, a bunch of packages, maybe Visual Studio Code, all the things that I need to do my scientific research. And that would just be my computer. Now, if I wanted to maybe share my work with a colleague, we're working on the same thing, we would have to coordinate and have everything exact, make sure we had exactly the same setup so we could ensure that whatever I'm running, they could also run. In addition, we'd have to figure out how we would share all the data, say. And now imagine that it's not just two of us, there are 20 of us, and we all, or 100 of us, and we all want to be using exactly the same environment. That would get really hard, especially if the setup and the installation were a bit tricky. Say it wasn't just R and Python, it was a whole bunch of other things we also had to install. This is a situation where containerization is really powerful. In containerization, we create a container, it's like a package, and that is this self-contained thing that has our operating system, all the packages that we need, any binaries, and it's all self-contained. And we can take that self-contained thing and we can run it, an identical copy, on a bunch of different machines, different laptops. And if we can do this in a clever way, we wouldn't even have to care what type of laptop it was. And for example, we could run these containers in a browser, and all you need is a browser. In a scientific context, the containers look kind of like this. So for example, let's say I was doing something geospatial in Python. So I might have Pangeo, maybe I'm doing some machine learning, I have some machine learning packages, maybe a whole bunch of modules. In R, if I were doing geospatial, I would have my rocker geospatial image, let's say, and then a bunch of packages. Or maybe I have a whole bunch of languages. Or perhaps I have some type of specialized environment. For example, here is a environment that's used in bioinformatics and genetics. So I have those, and then also on top of that, I have however I'm going to be running this environment. And within containers, you can have a bunch of different ways that you would run things. So JupyterLab, RStudio, Visual Studio Code, MATLAB, and obviously a terminal. Those are really popular ways you might interact with these environments. And these together, so each of these is one container plus whatever of these you have installed. That together is your container. A really popular way to run containers is JupyterHubs. This is a multi-user platform for running containers. We call them images. And within a JupyterHub, you can run this in a browser. You would access it in a browser, and you log in, and you are given a choice of what environment you want to spin up. You grab that environment. It'll come with something like this, some of these, and you log in, and then you're spun up in a virtual machine where you can do your work. And it's just that environment in that container. Somebody else logs on. If they choose the same container, it's exactly the same. So why are JupyterHubs so popular? Well, it removes the whole software and package installation problem, even for really complex environments. You just don't think about that. You just select the environment you want, it's all set up for you, and you drop right in. So everyone's environment just works, and you know it's identical to everyone else on the team. And in addition to that, a nice thing about JupyterHubs is you can set them up so that you can pick the power of the machine that you need. So if you are loading in a lot of data into memory, a lot of images into memory, say, you would need more RAM. So you just pick more RAM. If you're doing something where you need a lot of cores, you're doing some parallel analysis, or you need GPU, you could select a machine like that. So there aren't those barriers to getting your work done and getting the compute configuration that you need at that time for whatever analysis you're doing. JupyterHubs are widely used within the scientific community. You can set it up on your own bare metal server, just buy a machine, put it under your desk and set it up like that, and your whole team can connect to that. Many universities have managed hubs, and there's also companies that will manage hubs for you. 2I2C is a really big player in this. They manage hubs for a lot of universities, NGOs, and government. I'm most familiar with 2I2C hubs. So a few examples. CryoCloud is a Jupyter hub for the cryosphere community. It's community that studies some ice and snow. NASA Veda, this is one they have for working with their satellite data imagery. This was a hub that I used in a machine learning hack week that I taught recently. And the NASA OpenScapes team also has a 2I2C hub, and they do a lot of trainings on this, and it supports like 40 members from the data centers, and then they have 5 to 10 workshops, maybe more, per year. They teach a lot of workshops off this. And when you log in, you see something like this. So you can pick the environment. They provide 3, or you can provide your own image. So you can customize your environment and just provide your own image. You put a link to it here. You can start up in that environment. And it's a little hard to see here, but this dropdown is the size of machine that you want to run on. So you can choose more RAM if that's what you need for the task at hand. A really nice thing about JupyterHubs is that it is open infrastructure. It's cloud agnostic. It's all open source. You can put it on any cloud provider. It's very well community supportive. They're easy to install and set up. A nice thing about the images also is that they too are infrastructure agnostic. You can drop it into the Jupyter Hub, spin that up, but you could also run that, on your computer using Docker, Podman, run it on Bender, GitHub Codespaces, GitLab. These images, where do they come from? You can build your own. Docker images are not that hard to make. Nowadays, you just look up somebody's Docker file, you can see how it's done. The more complex ones are a bit harder to set up and have them build so they're not too enormous. And these are typically community developed base images, and so there are people who spend a lot of time making sure the image is good and stable, and then a very large community will use those images. So the Jupyter data science stacks are one example. The Pangeo geospatial stacks, there's the Rocker R stacks. Those are examples. And then also specific communities will like bioinformatics community will create images for their tool sets. So what are the sort of costs for running a Jupyter Hub? You can spin up your own. I put there, I don't recommend. I mean, a lot of people do. I have run many of them. It's actually very, very common for people to run their own Jupyter Hubs. It's not that bad. Um, let's see. Yeah. For me, recently, when I've run mine, it was about $500 a month for 3 people full time doing some machine learning. So just to give you a rough idea, the price there. If you were to get one with 2i2c, and this would be, you could have, like up to like 400, 300 people. You're looking more about, $50K per year, give or take. You can look at these QR codes if you want to see some examples of me running Jupyter Hubs. And that's it. Thanks a lot.